Hi everyone, my name is Nguyen and today I'll be talking about the final project for computer vision, which is classifications and detections using convolutional neural networks. So in this project we'll be using TensorFlow and Keras library to basically train a model and use it for detecting the numbers in the image. Um, so here is the website for TensorFlow that we'll be using for installations and small tutorials. Um, we also use Street View house numbers dataset provided to us from Google Street View images. Specifically, we'll be using format 2, which is the pre-processed dataset. And they're all in a 32 by 32 small patches of numbers here. Um, on the left right here is the project code in the IDE that I set up. So as you can see, I have a README of all the software requirements and what we got to do in this project. So first of all, let's walk through the project structures here. So I have at the top level, I have something called CNN Keras Pi. This is the model that the class that defines all the models. So basically we have three, just the basic CNN that I have, which is basically a small version of VG16 that has a convolutional layer, a max pool layer, a dropout, and then a second layer, similar layer. And down here is the fully connected layers. So it's increasing in size. We got a 32 for the first layer, 64 for the second layer, and 128 for the third layer. So there's some parameters you can tune to choose your optimizer. We'll go through that later. And then down here, this is basically reusing the VGG16 model from Keras. And down here is the models where you use the pre-trained weights from ImageNet. And so I have to do some tweaking to be able to use that with the input image is 4848 because by default they requires 224 as the input. And then basically what I did is I freeze the convolutional layers and then just train on the fully connected layers. And then at the top level, we got the experiments folder. This is basically where I structure my code to train all the agents, all the models. So let's step through that. So this file basically reading the data that I have and then run through the training sample and save the weights. This is for the simple model. Another version for the VGG16, and this is the version for the pre-trained models. Besides the training part, I also have parameter tunings. This is the batch size parameter tuning. So basically I'm training on 40,000 images, and so just simply like running through 32, 100 and 500 batch size to see which one is the most efficient, and then we use accuracy as a measurement here. We also have learning rate tuning, and then loss function tuning, optimizer tuning. This is the little callback that I wrote. Basically, they will attach to the fit method to graph the plot while it's training. And then the last file in here is the CNN test, which is basically evaluate all the models on the test set. As you can see here, I'm loading the test sets from the data loader and running all three models. This is the pre-trained VG16 without any training, and this with training, or retrain. So in this folder, so we got project data. This contained the entire data set that we have. It's about 20 gigs because I have to resize it to a 48 by 48 pixels for consistency. I also have generate non-number data set as well. So then we have 11 class total, 0 to 9 plus a non-number. Then in here, this is the output image that I generated from the training process as well as parameter tuning. So we can see it looks like this. So the 100 bat size is the most optimal. Then this is the output of the training process. As you can see here. So the VGG16 training from scratch is the most efficient model. So I'll be using that for the number detection tasks. So that is the experiment folder we have, and down here we got input images. So these are the images plus the video that will be shown, that will be used for the number detections and for grading as well. As you can see, these are all the original images that we'll be using. This is handle rotation. This is the blurry versions for Gaussian noise, multiple locations with different lighting. And down here we have the train weights folder. So this is the folder that contains all the weights that I've trained from the experiments folder here. They'll be stored here, and then once you use one of the model, you can just simply load the weights and apply it, so you don't have to retrain. So at the top level, we got number detections file. So this contains the core logic of the number detection task. So in here, as you can see that I instantiate the Keras VGG16 because that's my best model. So I believe it got 99% accuracies on the training versus the simple version got 92%, and then the pre-trained got only 82%. So I decided to use the VGG16 training from scratch. You can see here, I load the training weights. So for number detections, basically the technique that we're using is a combination of sliding windows and using image pyramids. So the idea here is to go through the image patch by patch and then apply the classifier on it to see whether it's an image or not. And then if you can't find anything, resize the image to a smaller version and then continue the process. And as you can see, the logic's reflected here. So this is the entry point for image detections. So I call the pyramid image, which will produce different size and different levels. And then we go through all the windows and then essentially collecting all the windows here and then feed it through the classifier. Essentially, what produces out here is an NumPy array of all the predictions. So each element contains 11 probabilities of from between 0 and 9 and a non-number. And then for this, I simply filter out anything that is anything that's not a number, and then the prediction is passing a certain threshold. And then basically just go through the process. So there has to be some grouping that's happening here. So if using the same label, I basically group them into this hash. And then so this process is happening for every pyramid, every layer in the pyramid. And then the last step would be merging the pyramid. So essentially you have to resize the scale version to its original form before you show the bounding box. So there's code that through that, and then essentially down here, the last steps that I have is combining the bounding box that are close by I'll show you the output image in a bit. So then just write it to the graded images folder for the TAs. And down here is a little bit on the clustering algorithm that I was doing for the merge pyramid. Combining predictions is, and then there's the combining bounding box. I'm using Euclidean metrics in this project. So let's go through the output a little bit. So this is a sample output of what I have is running through the original image that is blur. It's detected the bounding box between 5 and 9s, and we print out 59. So this is the scale version that's handling scalability. So this box is a lot bigger than 48. So 48 is about here. Essentially, on the first run, it will not be able to find number 5. It has to rescale it by half, and then continue searching using sliding windows. It will essentially detect this. And then at the end, so I have to rescale it back to the original image, and then also scale the bounding box to detect the number 5 here. So that's about like 200 by 200 pixels or something like that. Here's another version with different fonts. It's horizontal number set versus the number 1 is vertical. So you can see here. This is different locations with different lighting. For 5, it's we handle rotation as well. So I rotate this guy to be 45 degrees, and it's still able to detect number 7. That's my apartment number here. So let's go through a little example of how the code's going to run using. So I turn on a debug mode here, so that you can see the output. As you can see here, it's sliding through the windows, and it's turning yellow, flashy yellow when it detects a number. So it's just little debugging tools that I built for this task. And that's it. That's basically the project that I did, and the video is included in the reports. So you can check it out to see the video that I produced for handling all this case. Thank you.